Alright guys, today's lesson is over 1.2 inverse functions, so follow along in your note packet or on Scratchboard. We use the following functions to graph the compound function m of x. We see that we have f of x, g of x, and h of x listed. So the first question says m of x equals 2 times f of x plus 3. So we want to just simplify this by plugging in the function that it asks for, which is f of x right here. So we're going to plug in f of x for this equation. Okay, now to simplify this, we're just going to distribute 2 times 3 of x is 6x, 2 times negative 2 is negative 4, plus 3. Combine like terms and we get 6x minus 1 is what m of x equals. Okay, the next step is simple. We are just going to graph these just as if they were any old equation. You've learned this since pre-algebra in 8th grade. I know that because I have once taught it when I taught 8th grade. So first step, we want to graph the y-intercept, which is negative 1. So I'm going to plot that. And then I want to plot, or use my slope to plot more points. So looking here, 6 is what's in front of that x, and we know that's the same thing as 6 over 1. So we're going to rise 1, 2, 3, 4, 5, 6 points, go over 1, and plot another point there. We only need 2 points to plot a line, but we can make more. We know the opposite of going up 6, right 1 would be to go down 6 and left 1. So the line is going to look something like this. Not super straight, I'm not an art teacher, so it's not perfect, but you get the gist. Okay, moving right along, we do the same thing on these other two functions. So go ahead and pause here and try to complete those on your own. Alright, so what you should have done for these, m of x equals negative gx minus 6. So negative gx, we've got a negative, and then our g of x function, which is negative x minus 4, minus 6. First things first, distribute out the negative. This becomes x plus 4, minus 6, which becomes x. There's that bell. X minus 2. Okay, so that's what m of x equals. Now just time to graph it. First things first is our y-intercept, and then our slope on this one. We see we just have an x, so the invisible number in front of that is just 1, which is the same thing as just a 1 over 1. So our slope is just 1. Rise 1, run 1, rise 1, run 1. And there we go. Next one, we see we've got 2h of x plus 1. So 2 times negative 2x plus 1 plus 1 here. So I just plugged in my h of x into my m of x function. Simplify. Negative 4x plus 2 plus 1. And combine like terms. It just becomes m of x equals negative 4x plus 3. And we'll go ahead and graph that one. As you can see, my graph cut off on these slides. What a bummer. But I'll just go ahead and try my best here. So my intercept would be 3. Slope is down 4, right 1, which is the same as up 4, left 1. Something like that. Okay. So that was just a little graphing review. We'll move right along. Inverse functions. So this is our big thing we're talking about today. So inverse functions reverse and original functions. We have the notation f to the negative first of x, and that stands for the inverse of f of x. The graphs of the inverse of f of x will always be symmetric with their original graph around the line y equals x. Okay, we know that the line y equals x. The intercept on that one is 0, okay, and the slope is 1, so it's just literally a straight line that goes through the center of the graph just like that. I'll erase that just so we can keep going. But verifying the inverses, this isn't too hard, so we'll go ahead and go over how to do this. But what you want to do is just substitute one function into the other and simplify. If you're left with just x equals x, that means, yep, it's true. These are inverses. So let's go ahead and me fix these notes here. So this is 2x plus 6 is what that should say. Okay. First things first is I want to perform f of g of x, just to see if I get it to verify out. Okay? So f of g of x means I'm plugging in g of x everywhere where there's an x in f of x. So I get 1/2 to x plus 6 minus 3. Go ahead and simplify. 1/2 times 2x is just x. 1/2 times 6 is plus 3 minus 3. Does that equal x? Yes, these 3's cancel, right? X does equal x, so therefore that does check out. That verifies. Now I got to go the other way though. I need to know if g of f of x also equals x. So same thing, or sorry, not same thing, opposite thing. I'm going to plug in f of x everywhere where there's an x in g. So how I'll do that is I'm going to do 2 times half x minus 3 plus 6. Go ahead and distribute out. I end up with x minus 6 plus 6. Does that equal x? Sure does. The 6's cancel out, so that verifies as well. So we did just verify this. Now it wants us to graph both the lines to show if they have symmetry or not. So my first graph is right here, half of x minus 3, that's f of x. So I'm going to plot my negative 3, rise 1, run 2, because that is my slope. Okay. Then we've got 2x plus 6, rise 6. Plot that. Up to right 1 or down to left 1 is going to be the slope on that one. And that's it. So what it wants to know, it wants to know if that is symmetrical. Just by looking at it, I can see that if I were to graph that line y equals x, these would be symmetrical over that if I were to flip them. So that's how you can tell just by looking at a graph if two inverses, or if two functions are inverses, is if they are symmetrical about that y equals x line, which is the line I just graphed in blue. Okay, we've got another verifying problem, so go ahead and try this one on your own. Go ahead and work it out both ways. So pause here. All right, so first things first, we're going to do f of g of x. Okay, so plug in g of x into f of x, and when we do that, we will get square root of x minus 1 squared plus 1. Anytime I have something in a square root that is being squared, I know that those just cancel out to give me just what's left under that square root. I still have a plus 1 at the end. Does that equal x? It sure does. X equals x, that verifies out. Now we've got g times f of x. Okay, we'll try this one. So using this function, plugging in my f. Okay, go ahead and simplify what's under the square root. 1 minus 1 is just 0, so this just became square root of x squared. Does that equal x? It sure does. So that verifies out. So that is another verification problem. Hopefully you got that one. Last big thing we've got going is we have finding the inverses of functions. So we have these 4 steps at the top. The first one is to rewrite f of x as y, then switch the x and the y. This is how you actually get the inverse, okay? Solve for that new y, and then write it in the new notation. So this sounds like a lot. Let me break it down and show you why this really isn't too bad. So first things first is just to rewrite f of x as y. So all I'm doing is just making this f of x into a y. Okay, next step is to switch the x and the y. So everywhere where there's a y, I'm going to put x, and everywhere where there's an x, I'm going to put y. Don't change anything else. Next step is just to solve for the new y. So to do that, I'm just going to solve this equation. Move that 6 over. This becomes x minus 6 equals -1/2 y. I want to kill that fraction. So I'm going to multiply both sides just by a -2, just so I can get that y by itself. So y equals -2x plus 12. And then the last step is just to rewrite y as f to the -1st of x. So that's what I'm going to do, is just switch that y into f to the -1st of x, and then I'm going to put -2x plus 12 on the other side, just because this looks prettier. And that's my answer. Okay, go ahead and try the next two. They work the same way. Okay, let's go ahead and try these out. Rewrite f of x as y. Switch the x and the y. Solve. Subtract 1. Divide by this -3. When I do that, y becomes -1/3 x, or just -x over 3, plus 1/3. Last step is just to rewrite it. So f to the -1st of x equals -1/3 x plus 1/3. Okay. And then we've got one more here. So we've got f of x equals x minus 5. So first step, y equals x minus 5. X equals y minus 5. Add 5. X plus 5 equals y. Inverse of x equals x plus 5. And that's the gist of it. Let me know if you have questions. That's all I've got for you today. That is how you find the inverse functions. Your homework will be on Canvas. And again, let me know if you have questions, guys. I'll talk to you later. Bye.